So we're going to stop here for a second and look out at the forest and talk about how it's changed since we started. So when we first started, we learned a tree that we don't see anymore. Anybody remember what that is? Do you remember the trees that we learned? We learned spruce. We see spruce. Pardon? Alder, exactly. So there's no alder because we're in a mid-range forest. So this avalanche allowed these trees to be knocked over, and we were able to count the growth ring. So we know this forest is around at least 120, 125 years old. And in this age of a forest, there's no more alder. It's a quick start. Grows quickly, grows kind of as a scrubby tree at first, and then it's short-lived. So it does very well in the poor environment with no black dirt and very little nutrients. Remember, it's a nitrate fixer, so it fixes nitrates into the ground when it sheds its leaves, so it's deciduous. And along with that, this bark right here that looks vertical, looks like bacon strips, some people say, that's hemlock. And the one that looks more scalloped like fish scales, that's spruce. So now that you know the two barks of the trees that we're seeing here, which tree is the oldest in this age of the forest? Spruce, yeah, exactly. So the spruce is bigger, taller, and that's because it likes the sunshine. It has needles that go all the way around it. And the hemlock has the flat needle structure. It's a solar collector, so it does very well in the shade. What is the only tree that you're seeing right now in the understory of trees? What's the tree that we see in the understory? There's really only one. Hemlock, you got it, hemlock. So it's a flat needle structure. It's a solar collector, so it does very well in the shade. So if you look out there, those are all hemlock trees that you're seeing. And so eventually, the spruce will reach their maximum growth and age, and they'll die off. And then it'll become a predominant old-growth hemlock forest. And then you were in Ketchikan, and in Ketchikan, the old-growth forest contains a lot of yellow cedar. We don't contain as much because we have less rain, and yellow cedar need a lot of rain, and climate change has caused this area to be drier. So we don't have that many yellow cedar, but they can live to be over 1,000 years old. Did any of you hike in an old growth forest in Ketchikan? No? Yeah? Yeah, wasn't it pretty? The big, huge spruce tree. So you're seeing a whole different aspect. Yeah. And if you haven't done that, then you really don't know what the difference is. But they're enormous old trees. And that's because the glacier there was there a long time ago. And then in this area, we actually just hiked up above the lateral moraine. So when the glacier bulldozer is grinding off the mountains, making the deep U-shaped valley, it's acting like a bulldozer blade. So it's pushing the big rocks, those glacial erratics, to the side, just like a bulldozer would. So all the big rocks are in a vertical row along each side of the valley at around the same elevation. And we hiked above that because that's where the bear was leaving the marks on the marking posts on the rails there. So we hiked above that, which means the forest is older because we're above the ice from the edge of the glacier during its advance and even its recession. Does that make sense? So it's kind of unique. So it's sort of counterintuitive to what we would see in most forests as we're going up. The forest is growing older. We're going to climb up a massive set of stairs, and then we can take a little rest and use the facilities.